So this part of the unit is about mole conversions. We've already done mole conversions before, okay? But there's just an added twist to it that makes it not any more difficult, just maybe a little bit more in terms of stuff you might have to do. So, once upon a time, a long time ago, we talked about mole conversions. We talked about things like mass. We talked about things like moles. And we talked about things like particles, at least if you were in my class. In particles, we also talked about them in terms of atoms and molecules and something called a formula unit. So we have mass, we have moles, we have particles. At some point or another, you were asked to be able to convert from mass to moles. And when you were asked to convert from mass to moles, what did you need? Or where did you get that information? Does anybody remember where you got that information when you converted, like, say, mass of sulfur to moles of sulfur? Your periodic table, which is why I asked you to get it out. So the mass in grams is going to come from the periodic table. And then when you were asked to go from moles to particles, which is something that we did, you were supposed to use a very specific special magic number. Does anybody remember what that is? Yep, it's 6.02 times 10 to the 23rd, also known as Avogadro's number. Now that's going from mass to moles and moles to particles, but now we can also go from particles back to moles, in which case you will use 6.02 times 10 to the 23rd. But then you can also go from moles to mass, in which case you can get that mass from the periodic table. Oh, geez. Now, on Friday, we learned to calculate something called the molar mass, and that molar mass came from the periodic table. So that means that when I say it's from the periodic table, now we're talking about the molar mass. Okay? So, you learned a skill on Friday. That's the molar mass, or Thursday, rather. And now we're going to apply it. But before we really get into applying it, we need to kind of go back in time and refresh our memory about a couple of things. First of all, mole conversions have some different units or labels than what we used in the past. So the smallest unit of a covalent compound, and just to refresh your memory, covalent compound is made up of a nonmetal and a nonmetal. That smallest unit of a nonmetal covalent compound is known as a molecule. The problem is that people out in the interwebs and newscasters don't use the word molecule correctly. They use molecule for like everything, and that's not true. There is another word that we use to describe an ionic compound. And remember, an ionic compound occurs between a metal and a nonmetal. And that is a formula unit. Okay? So we have these things called molecules, which we reserve for covalent compounds, and formula units, which we reserve for ionic compounds. Now, the formula unit, you can abbreviate FU. Okay? But there's really no abbreviation for molecule, so you got to write that one out. Now, let me try to explain a little bit of what's going on here. Water molecules are an individual molecule of water has a formula of H2O. That actually translates to 2 hydrogens and 1 oxygen are combined together to make water. So every individual water molecule has 2 hydrogens and 1 oxygen. But in an ionic compound, the NaCl, for example, on this particular slide, that doesn't mean that there's one Na and one Cl. What that really means it's the ratio of Na to Cl. So it's 1 Na for every 1 Cl. So if you have a singular crystal of table salt laying on your table, there could potentially be millions of sodium ions and millions of chlorine ions in a ratio of 1 to 1. And that's the difference between a formula unit and a molecule. But that's not super important for today. You just have to know when to use what. We also learned once upon a time, long time ago, that 1 mole of anything is equal to 6.02 times 10 to the 23rd of that anything. So 1 mole of covalent compound is equal to 6.02 times 10 to the 23rd molecules of covalent compound. 1 mole of formula unit is equal to 6.02 times 10 to the 23rd formula units. Yes, sir. Yes, sir. Now, the best way for us to learn how to do this, or to refresh our memory, as it should be for many of us, is to do an example or a few. So, here we go. In this problem here, I see that I have 2.27 times 10 to the 23rd molecules of PBr3, and the problem is asking me to convert it to moles of PBr3. So what that tells me is I'm going to convert from molecules to moles. And you may recall that when we did these conversions in the past, we always had to look for a relationship or a conversion factor. So I'm going to do the same here. So we're looking for how many molecules of PBr3 are equal to moles of PBr3. And the answer to that question is based on the slide up above. So 1 mole of anything, in this case PBr3, is equal to 6.02 times 10 to the 23rd molecules of PBr3. So now that I have my conversion factor set up, I'm going to take my given, which in this case is going to be 2.27 times 10 to the 23rd molecules of PBr3 over 1. And because I'm going molecules to moles, that tells me it's going to be a one-step problem. And I need to set this problem up so that my units cancel out. So I'm going to put molecules on the bottom and moles on the top. And I'm going to go and fill in my values. So 6.02 times 10 to the 23rd molecules, as we've said before, is equal to 1 mole. Now, I'm not going to do this next part for all the problem examples that we're going to do, but I'm going to do it now just to hopefully illustrate the situation. So what happens here is if we multiply straight across, right, you get something like 2.27 times 10 to the 23rd times 1, which really ends up being 2.27 times 10 to the 23rd molecules times moles of PBr3. The units kind of combine. And if I multiply straight across the bottom, I get 6.02 times 10 to the 23rd molecules of PBr3. And hopefully what you see here is that the unit of molecules cancels out because one's on top and one's on the bottom, and that's going to leave us with moles of PBr3. Now, what I would like you to do is I would like you to go ahead and... Someone stole my calculator.
Can you like divide the two and get your answer through there or no?
I would like you to do that math right now. So I want you to take a second and I want you to go ahead and calculate your answer, but don't actually write it down because I want to make sure we're doing it correctly. Okay? So you're going to basically take 2.27 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. And again, I don't want you to write it down yet because I want to make sure that you are doing it correctly. So in this instance, you should have gotten 0.377076412. If you got something different than that, sure. If you got something different than that, like, for example, you might have gotten 3.77 times 10 to like the 46th or 45th or something like that. If that's what you got, that tells me that you did not put this into your calculator correctly. And so in order to put it in your calculator correctly, we have to follow the appropriate steps. So we would take 2.27. So if you didn't get the same answer I did, please do this with me. Type in 2.27 and your display will say 2.27. Hit second and then the button above the 7, which is x to the minus 1. And your calculator will say 2.27e. Excuse me, sorry. Then type 23, and your calculator will say 2.27e23. Then you hit the division symbol, you get a slash. Then you type 6.02, so it's your display will say 2.27e23 slash 6.02. You then hit second, the x to the minus 1 button, which is above the 7, and you now get another e, so it's 2.27e23 slash 6.02e. Lastly, you type 23, and then this is what you should get, which is 2.27e23 divided by 6.02e23. That e is calculator language for times 10. Alan, your calculator is different. I'll come talk to you. Right. Everything's got to go in parentheses. All right. Okay. All right. Now, with that in mind, when you hit what? You're okay, just hit comma. Huh? You're okay, just hit comma. Okay. So with that in mind, you should have gotten 0.377076412 or something like that. If that's something that you're struggling with just a little bit, I do have a video that I will post about how to use a calculator and put scientific notation in a calculator. Otherwise, we have to figure out Sig Figs. So I draw my arrow and I count 1, 2, 3. So we have 3 Sig Figs. I draw an arrow down here and I count 1, 2, 3. So that's 3 Sig Figs. So my answer has to have 3 Sig Figs. So I draw my arrow to my first non-zero digit and I count 1, 2, 3. That 0 cannot round the 7 up. So my final answer here is going to be 0.377 moles of PBr3. Questions so far? All right, next one. In this case, you have moles of Li2O, and you are going to formula units of Li2O. So this problem, we are going to be converting from moles to formula units. And so, again, I'm going to need to know the relationship between moles and formula units of anything. So I need to figure out what makes FUs of Li2O equal to moles of Li2O. And from before, we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd formula units of anything. So in this case, Li2O. So now I'm going to take my given piece of information, which is 2.1 moles of Li2O, and put it over 1. And because I'm going moles to formula units, it's a one-step problem, so it looks something like this. I need to get rid of moles or cancel them out, so I'm going to put moles on the bottom. And I'm going to put formula units on top. Now I'm going to fill in my values. So in this case, 6.02 times 10 to the 23rd formula units is equal to 1 mole. I'm going to calculate. So I'm going to grab my calculator, and I'm going to take 2.1. 2.1 times 6.02 second, x to the minus 1, 23. And the calculator gives me a value of 1.2642 E24 it might give you. And the last time I checked, none of us are robots or computers. Last time I checked. Which means that none of you talk or think in computer programming language out loud. Which means that you can't leave it as an E, so you have to translate it into human language, which is 1.2642 times 10 to the 24th. Sig Figs, of course, though. So I'm going to draw an arrow here and count 1, 2. So I have 2 Sig Figs. I'm going to draw an arrow here and count 1, 2, 3. That's 3 Sig Figs. So I'm going to draw an arrow here and count 1, 2, 3. 3 Sig Figs. That 4 does not round the 6 up, so my final answer is going to be 1.26 times 10 to the 24th formula units of Li2O.
Why would it be 2 Sig Figs? I mean,
Yep, you're right. You're right. 3 Sig Figs or 2 Sig Figs. Sorry. I got carried away. You're right. It should be 2 Sig Figs. That 6 does round that 2 up. Now it becomes 1.3. Woo, thank you for catching that. It's been a long day already. Moving on. So, in the next problem, we are looking at 27.3 grams of Li3PO4, and we are converting it to moles of Li3PO4. So this one is going to go from mass to moles. And now this time, it just is going to be a little bit like one extra step, okay? So in order to figure out what the relationship is between grams of Li3PO4 to moles of Li3PO4, I get grams from my periodic table. So that means I have to calculate the molar mass of Li3PO4 first. So in this problem, there are 3 lithiums times the mass of lithium, which is 6.94 grams. There's 1 phosphorus times the mass of phosphorus, which is 30.97 grams. And there are 4 oxygens times the mass of oxygen, which is 16.00 grams. So I calculate all this business out, and I take 3 times 6.94, and I get something like 20.82 grams of lithium. Bring the 30.97 grams of phosphorus, and 4 times 16 gives me 64. The calculator does not give me 00, but I got to add it, grams of oxygen. So now we have to add all that stuff together, and you get something like 115.79 grams per mole of Li3PO4. The fact that it's grams per mole tells me, though, that for every 1 mole of this substance, I need 115.79 grams of that substance. That's what grams per mole means. So I'm going to take my given, which in this case is 27.3 grams of Li3PO4 over 1. And it's going to be a one-step problem because we're going from mass to moles. And when we go mass to moles, I need to get rid of grams. So I'm going to put grams of Li3PO4 on the bottom and moles of Li3PO4 on the top. And since we've already identified that the relationship between moles and mass of Li3PO4 is 1 mole of Li3PO4 is equal to 115.79 grams of Li3PO4, I can now go through and calculate. 27.3 divided by 115.79 gives me a value somewhere around 0.235771656. We have to assess significant figures, and hopefully I can do it right this time. So I'm going to draw an arrow here, and I'm going to draw an arrow here and count. So this is 1, 2, 3, 3 sig figs. This is 1, 2, 3, 4, 5 sig figs. So my final answer should have 3 sig figs. So I'm going to draw an arrow here and count 1, 2, 3. That 7 does round that 5 up. So my final answer is going to be 0.236 moles Li3PO4. Questions there? Okay. In the next problem, we have moles of IF5, and we are going to be converting it to mass or grams of IF5. So this problem is going to be converting from moles, I don't know what that is, to mass. And so if we're going to convert from mole to mass, you bet your bottom dollar we are going to need to calculate the molar mass. But we're looking at the relationship again between moles of IF5, thank you, and grams of IF5. Thank you. So like I said, we're going to be doing some calculating of our molar mass. So I have 1 iodine times 126.90 grams of iodine. And I have 5 fluorines times the mass of fluorine, which is 19 grams of fluorine on the periodic table. So let's see. 5 times 19 is 95 grams of fluorine. Add that to the 126.90. And I get something like 221.9. Got to add the 0 grams per mole of IF5. So that tells me that if I happen to have 221.90 grams of IF5, I really have 1 mole of it, and then everybody's happy. So now I'm going to go and add this to, or solve my problem. So I'm going to take these 0.921 moles of IF5, put it over 1. And because I'm going moles to mass, it's a one-step problem. And I need to set the problem up so that moles cancels out. So I'm going to put moles of IF5 on the bottom, grams of IF5 on the top. And so now I'm going to fill in my values. So 221.90 grams of IF5 on the top over the 1 mole of IF5. And so now I'm going to calculate this math out here. So 0.921 times 221.90 is something like 204.3699 or something in that ballpark. We need to figure out significant figures, so I draw a line to my first digit count. That's 3 sig figs. Draw a line to my first non-zero digit, and I count 1, 2, 3, 4, 5 sig figs. So my final answer has to have 3 sig figs. So I'm going to draw a line and count 1, 2, 3. That 3 cannot round that 4 up. So my final answer is going to be 204 grams of IF5. So we went mass to moles, moles to mass, mole to particles, particles to moles. Now we need to go and ratchet it up one more level. In this case, we have 2.14 times 10 to the 24 molecules of SO3, and we are going to convert it to grams of SO3. So here we are starting with molecules, ending with grams or mass. And the only way to get there, I got to scroll up for a second. If we're starting with molecules and we're going to grams, there's no arrow that goes directly from molecules to grams. So you have to go molecules to moles to grams. That's what you got to do. And so that's what we're going to do. So we are going to go molecules to moles to grams or mass. So it's going to be a multiple step problem here. First thing we need to do is figure out a couple of our relationships. So we are looking for the relationship between molecules of SO3 and moles of SO3. We know from earlier that 1 mole of anything is going to be equal to 6.02 times 10 to the 23rd molecules of that anything. The other thing that we need to look for is the relationship between moles of SO3 and mass or grams of SO3. And the only place to get grams of SO3 is from the periodic table, which means we have to calculate the molar mass. So I have 1 sulfur times 32.07 grams of sulfur. And I have 3 oxygens times 16 grams of oxygen, which is 48.00 grams of oxygen. Add those up. So I've got the 48 plus the 32.07, and we get something like 80.07 grams per mole SO3. So that tells me that if I have a pile of 80.07 grams of SO3, I have 1 mole of SO3. So now I'm going to set my problem up so all my units cancel and I get what I want at the end. So I'm going to start with my given, which is 2.14 times 10 to the 23rd molecules of SO3 over 1. And I'm going to go molecules to moles, and moles to mass. So if I have molecules on top, I'm going to put molecules on the bottom. And I'm going to put moles on top. And we learned that the relationship is 1 mole of SO3 or anything is equal to 6.02 times 10 to the 23rd molecules of that thing. I'm now going to go from moles to mass. And when I go from moles to mass, I'm going to put moles of SO3 on the bottom. And I'm going to put grams of SO3 on the top. We know that 80.07 grams of SO3 is equal to 1 mole of SO3. My units cancel. I'm going to grab my calculator. I'm going to do the math. So I'm going to take 2.14 second x to the minus 1, 23, times 1 times 80.07. And at that point, I'm going to hit equals. Then going to divide by 6.02 second x to the minus 1, 23. And I'm going to get, hang on, I miscalculated. Oh, it's 24. 6.14 second x to the minus 1, 24 times 80.07 divided by 6.02 second x to the minus 1, 23. That looks way better. So my calculator answer is going to be something like 284.6342193. Now Sig Figs. So draw an arrow here, and I count 1, 2, 3 Sig Figs. Draw an arrow down here, and I count 1, 2, 3 Sig Figs. Draw an arrow here. 1, 2, 3, 4 Sig Figs. So my answer's got to have 3 Sig Figs. So I draw an arrow here, and I count 1, 2, 3. That 6 will round that 4 up. So my final answer here is going to be 285 grams of SO3. Isn't this exciting? It's riveting, right? One more. You do it. Let's get a quick little talk about this real quick once here. We have 48.6 grams of Na3N, and we're going to go formula units. Na3N. So let's talk about that. So we're going to go mass to moles to formula units. This is my favorite type of problem to do. Ready, set, go. You do it. So just a quick check depending on where you're at. I went and calculated the molar mass. So go ahead and check that real quick once. Hopefully you fell somewhere close to 3.53 times 10 to the 23rd formula units of Na3N. Questions? Excellent. So that wraps up mole conversions with compounds. So enjoy. Remember, chemistry is try, not chemist cry.